look at that! Wow!
Dr. Earl, there you are! What are you doing?
Oh, my friends and I were taking a closer look at these awesome lava lamps. We're using our magnifying glasses to take a closer look and make some observations. Aren't they cool?
Definitely. Hey, Earl, have you ever explored the science behind what makes lava lamps so exciting?
Well, not yet, but we should.
Absolutely! You can make your own lava lamp. You probably have everything you need right in your kitchen. For this activity, you'll need a clear glass, tap water, vegetable or mineral oil, food coloring, Alka-Seltzer tablets, and if you have a flashlight, you can use it. Ask your favorite grown-up to help you find these materials and have them help you set up your experiment somewhere that you can easily clean up any spills. Let's fill the glass about 1/4 full of water. And then add a few drops of your favorite color of food coloring.
After that, find a grown-up and have them help you fill your cup the rest of the way with oil. Then, you'll want to find an Alka-Seltzer tablet and break it up into about 4 equal-sized pieces. Feel free to have a grown-up help you with that part, too.
Ready for the next step? You're going to take one of your pieces of Alka-Seltzer, drop it into the glass. What do you notice?
Oh, look at that! It's bubbling!
That's a great observation, Dr. Earl. I like how you're thinking like a scientist.
Hey, what would happen if we added another piece of the tablet?
Let's find out. I'll use the tweezers from my science kit. How long do you think it takes for the bubbles to stop going between each piece?
Seems to me like maybe 20 or 30 seconds. What do you think?
I want to try a different way.
Dr. Earl, tell us about your idea.
What would happen if you pour the oil in first, then add the water and food coloring?
That's a great question. Do you have a hypothesis?
Well, I think that it's not going to change, but we'll see.
That's a great idea.
I've got some oil here in my beaker from my science kit.
That science kit has so much helpful stuff in it.
It really does.
It's a good find.
Very cool. So, Earl, if you notice, I put the oil in first. Now I'm going to add the water. Let's see what happens. What do you notice?
It looks cool.
It definitely looks cool. The oil and the water are kind of all beating up, aren't they? Now I'm just going to add a little bit of the food coloring, and we'll drop in the Alka-Seltzer and see what happens. Oh wow, the food coloring is going down past the oil. Some of it's kind of stuck in there, but it's all spreading out in the bottom. And the Alka-Seltzer is still gonna act just like it did the first time. It's all fizzing. Do you see that, Dr. Earl?
Yeah, I do. I mean, I guess my hypothesis was kind of correct, right?
Yeah, it really didn't matter which order we did the operation, whether we put the oil in first or the water, because the oil all raised up to the top of the container. So when we were pouring the oil into the glass, you notice that the oil rose up to the top, whether we had the oil in the glass first or the water. That's because the oil and water have different densities. Density is a science word that just means the amount of matter or stuff in a substance. In substances that are more dense, the molecules are closer together. In substances that are less dense, the molecules are farther apart. We'll see you next week when we explore momentum. In the meantime, see what you can check out with that magnifying glass.
Hey, Earl, if I don't have a magnifying glass, where can I get one?
Oh. ScienceWorks is offering kits for y'all. Check the description below.
See you next week.
Bye! Hey, before you go, don't pour the oil down the drain. It could cause a clog. Ask your favorite grown-up for help cleaning up. You could put the mixture in a sealed container, then in the trash, or you could pour it outside. See you next time!